10 real system design interview questions from a Quest2Offer mock. Pause on each one, think how you'd answer, then I'll show you how. Let's go. How do you approach any system design question in an interview? Don't jump to a diagram. First, nail the requirements: functional and non-functional scale, read, write ratio, latency, consistency. Do a back-of-envelope estimate of traffic and storage. Then sketch the API and data model. Draw a simple high-level design. And only after that scale it with caching, replicas, and sharding. Close with trade-offs and bottlenecks. Structure beats raw knowledge here. Vertical versus horizontal scaling. What's the difference and the trade-offs? Vertical means a bigger machine, more CPU and RAM. It's simple with no code changes, but it has a hard ceiling and a single point of failure. Horizontal means more machines behind a load balancer, near unlimited scale and fault tolerance, but now you handle distributed state and consistency. Most systems scale up first because it's cheap, then go horizontal once they hit the wall. SQL versus NoSQL. How do you choose? SQL gives you ACID transactions, joins, and a rigid schema, perfect when relationships and strong consistency matter, like payments. NoSQL trades that for horizontal scale and flexible schemas, great for huge volumes or simple access patterns like event logs. Choose by your access pattern and consistency needs, not by hype. And remember, most large systems use both, SQL for the core, NoSQL where it scales. How does caching work, and what's the hard part? A cache holds hot data in fast memory, usually Redis, to cut load and latency. The common pattern is cache aside. Check the cache, and on a miss, read the database and populate it. The hard part is invalidation. You set TTLs or write through on updates, and you guard against a stampede where a hotkey expires and many requests rebuild it at once. Explain the CAP theorem and what it forces you to choose. CAP says that under a network partition, you can't have both perfect consistency and full availability. You pick one. A CP system rejects requests to stay correct, like a bank ledger. An AP system keeps serving and accepts slightly stale data, like a social feed. Critically, this only applies during a partition. Even without one, you still trade consistency against latency. That's PAC-ELK. Real systems tune it per operation. Quick pause. These are real questions from Quest2Offer's AI mock interview. Pick your target role and level, answer out loud or in writing, and get a breakdown of exactly where you'd get cut. It's free to try at Quest2Offer.ai. Now, back to the questions. What is sharding and what's the biggest risk? Sharding splits one big database into pieces by a shard key, say user ID, so each server holds a slice and you scale writes horizontally. The biggest risk is a bad key that creates a hot shard, where one partition takes most of the traffic. You also lose easy cross-shard joins. Pick a key with high cardinality and even distribution, and consider consistent hashing so adding a shard doesn't reshuffle everything. What does a load balancer do, and what's L4 versus L7? It spreads requests across many servers, runs health checks, and removes dead nodes. That's how horizontal scaling actually works. Layer 4 balances on TCP. Fast, but it only sees IPs and ports. Layer 7 balances on the HTTP request, so it can route by path, header, or cookie, terminate TLS, and do sticky sessions at a bit more cost. Common algorithms: round robin and least connections. Why put a message queue between services? A queue decouples producers from consumers so they don't need to be up at the same time or run at the same speed. It absorbs traffic spikes by buffering while consumers drain at their own pace. Natural back pressure. It moves slow work like sending email or processing video off the request path with retries on failure. The cost is eventual consistency, and consumers must be idempotent. What problem does consistent hashing solve? With plain modulo hashing, adding or removing a server remaps almost every key. A cache or shard cluster melts down on every scaling event. Consistent hashing places servers and keys on a ring, so adding a node only moves the keys between it and its neighbor. A small fraction, not everything. Virtual nodes smooth out the distribution. It's the backbone of systems like Cassandra and the original Dynamo design. A system is read-heavy at massive scale. How do you serve it? Layer it. Put a CDN in front for static and cacheable content so most requests never reach your origin. Add a cache like Redis for hot data. Use read replicas so reads fan out across copies while writes go to the primary, accepting some replication lag. Denormalize where joins are expensive. The theme push reads as far from the database as you can. That's all 10. How many did you get? Tell me in the comments, and like, subscribe, and try a real mock interview at Quest2Offer.ai. Good luck out there.